spinning snowman looks three-dimensional, but believe it or not, it's made up of nothing but two-dimensional scratch sprites. Today we're going to be building this snowman and learning all about 2.5D, an animation technique that takes flat sprites and creates the illusion that they're spinning in 3 dimensions. Let's get right to it. So the inspiration for this project and most of the code that we're going to be using today is from a scratcher named Yucks. That's Yucks with 2 S's. And he made this project called 2.5D Magic Elephant way back in 2015. And I'm really impressed by what I'm seeing here. Let me click the green flag and show you what's going on. So we start off with a little elephant here, a very cute anime looking cartoon elephant. But when then I hit some directional keys, I'll move my A and my D key here, you'll see that the elephant spins around and we can see it in 3 dimensions as if it's actually spinning around on the screen here. Fascinating, really cool. And we can spin it in either direction depending on what key we're making. And what is super cool about this is if you look at any of the individual sprites, like the ear here for example, you can see that it never actually changes. It flips at one point and it changes in size, but the actual costume never changes. So we're doing this entire illusory 3-dimensional effect simply by moving sprites around and changing their stacking order and changing their size. The math behind this turns out to be fairly complicated. We're getting into some trigonometry again, and I'm here to tell you today you don't really need to understand that to make this happen. I'm going to show you how to remix a project like this, and we'll be able to take this and you'll be able to design your own graphics and create some kind of a cool 3D character of your own if you just follow my simple instructions. So let's get started on that right now. So if we have a look under the hood here, you can see there's some interesting stuff happening in the code. Let me just give you a quick overview. Over here in this tall left-hand stack here are a series of commands, each one for a different costume that this elephant is going to wear, and each costume is a body part. So the main body is kind of floating in the middle here, and it doesn't move or change at all. It's very important that these bodies be round because you can't really duplicate a square turning around or any kind of a shape with corners. So we're going to need a soft-bodied object to do this kind of thing. And then we've got ears and eyes and a tail, and you can see a lot of these objects are offset. We'll be talking about that in a little bit. We've got a hand, a belly, which is, I don't even see it here, it's in white, I guess. There it is. And a piece here for the trunk, the tip of the nose, and a foot. So each individual body part is its own little 2-dimensional object, and what this code is going along through here is creating clones. It's switching to the costume for that body part, then creating a clone, and setting a couple of local variables here that we're going to be talking about in a little bit. The rest of the code, we just have some code here that changes one of the variables called move with a directional button. And down here at the bottom, we've got something that just initializes the initial body costume. The real action takes place inside here, and I want to break down this code with a little simple example to show you a little bit of what's happening here. The trigonometry I talked about is right here. We've got a cosine and a sine command here, and a whole bunch of complex math happening to these. We're not going to go looking into what cosines and sines are about. You're going to learn all of this in high school, and it all has to do with the relationship between sides of a triangle. It's trigonometry, which is actually turns out to be a really, really useful branch of math that you can use in engineering and construction and stuff. But it's super handy for video game development because generally speaking, when you use a sine or a cosine, you end up with an oscillating kind of pattern where a number gets bigger and then smaller and then bigger and then smaller. It basically is making a number go from -1 slowly up to 1 and then back down to -1. And all we have, if we just change one variable, make it keep going up, we're going to get this constant oscillating cycle where things go up and down and up and down. So I've got a little isolated project here that just has little bits of this code in here. I want to show you how it works here. So I've taken the part with the go to X here, and instead of having it attached to a body part, I've created a little sprite here just for a little red object that I'm going to move around the screen. So you can see this is a go to command, which means that we're going to be changing the X coordinates. So the Y coordinates here are just 0. So this object's always going to be stuck in the middle. The X coordinates are going to change according to this formula. And like I said, it's all about oscillating back and forth. Now the two variables that are involved here, we've got one called Z position. I've renamed this to make it a little more obvious. The yucks actually just use an exclamation point here. So the Z position is basically how far your object is away from the center of the screen. And the move is basically a variable that starts the thing spinning around in a circle around that object. So we don't have any variables set here, so I'm just going to go ahead and we're going to set the Z position. I picked a random, just a number here, 500, and we're going to see how that works in a little bit. And this move variable, we can change it constantly, or we can change it with a key press. I'm going to pop it in here, and we're just going to have this variable keep going up by 5 all the time. It doesn't matter where it starts or where it ends. It's just a number that's going to make the thing start to oscillate. So when we run this equation through here, watch what happens here. So what's happening is our object is just sliding back and forth in the typical way that you get when you start to use trigonometry functions. It speeds up and then slows down before it gets to the end, and kind of does a bit of a rocking chair kind of motion back and forth. Now as I change these variables around, if I change this this Z position variable, the higher this number gets, the wider the oscillation is. So if I go to 1,000, for example, it goes quite wide, or 2,000 here, you can see what's happening. So this object, so we're going to imagine it kind of spinning in three-dimensional space here. Now right now it's just moving left and right. To get it moving forward and backwards as well, we're going to have to change the size to create that illusion that's getting closer to us and farther away. So we're going to change its size in the same way that we're changing its left-right coordinates here. I'm going to pop this purple bit of code in here, and this is going to change the size of the object to a number between, so we're going to start with 100%, and we're going to, once we run it through this formula, you see we're going to end up with a number that's going to go from smaller than 100 to bigger than 100 and over again. Let's see what this does once we pop it in here. Now we've got the thing spinning around in a nice circle. Let's look at the size down here. You can see that we're going from a low of around 60 to a high of around 140. And it's just constantly doing that over and over again. And we already have this kind of 3D effect going, which is really cool here. Now, so that's really the core of it here. Now, the problem, though, is we're interacting with other objects here as well. So we're going to want it spinning around a different object. As soon as we get this cat into the picture here, you see that that's not really happening. So to create the illusion that the thing is actually spinning around the cat, we're going to need it in the foreground sometimes, and in the background other times. So you can see that once we get to the foreground here, it's always bigger. We're swinging from a number smaller than 100 to a number bigger than 100. So if we key in on that middle number, which is 100, we can add a little bit more code here that says if our size is greater than 100, then we must be to the front. So we're going to move it. Well, instead of saying go to front, yucks here says go forward 100 layers. And if not, we're going to go backwards 100 layers. And that's basically setting it to the front or setting it to the back. He's just gone about doing it a little bit of a different way. So just as soon as I pop that in here, you see we've got something a lot more remarkable happening here. It actually does look like it's spinning around the thing. So we've created basically a fake version of 3 dimensions here. Really cool. Now there's one other little bit of code here that we're going to use in this block, and that basically flips this object around, and so that it actually looks like it's rotating. We're going to want this to be part of our object in the middle here. So we're going to want it to appear like it's sitting in one position and rotating around rather than moving like this. We want it to move like this to pivot. So that's what this code is going to do. Watch what happens when I pop that in there. All it does is it flips the thing around. And now if you can imagine this sitting in the middle of an object here and spinning around, you can see that the arrow is always pointing towards the middle of it now, which is really what we're trying to accomplish here with our 2.5 dimensional effect. Okay, so we're going to take all of this code and now we're going to design our own creature. I'm going to start basically with the same code from the 3D elephant project, and I'm just going to design myself a little snowman. And let's get to work on that right now. So I've got a starter project up here. And unlike most starter projects, this one already has most of the code in it for you. All that we're going to be doing today is building up this stack of objects here that's going to clone our objects and move them around based on how that move variable changes. And we're going to position them based on how far or how close they are to our snowman's body here. So this is the body I've designed for my snowman. You can see that it's just a blank snowman. Now the hat is going to look the same no matter which direction that we're in. I did design this hat separately in Scratch. I think I did a lovely job on it. And no matter which direction that we're in, the hat's going to look the same. And that's an important part of this. Every part of the main body of our object has to be something that looks identical no matter how it's spun. We're going to decorate this with eyes and other stuff in a little bit. And when that happens, you're going to see those parts spin around the object, but the actual body has to be mostly still. And so that means you have to design something here. It doesn't have to be a snowman, but it has to be something that's curved in shape so that it looks the same no matter what direction you're looking from. So that's what we start from in the middle here. And then we're going to start at adding body parts to it. So you can see our code is exactly the same as we set up here. We've got our trigonometry functions here and all the other stuff that makes stuff go to the front and to the back. So the code that puts these body parts down is going to be over in this stack here. And it's really just going to be a repetition of these 4 blocks over and over again, once for each body part. So what's going to happen is we're going to switch to the body part we want to place down, in this case the arm. We want to give it a move variable, and you're going to see in a second here, that's going to help us position it on top of our snowman body here. And then we're going to set a Z position, which is how far away from the center the thing is as it spins, how widely it oscillates back and forth here. Now remember, the code over here is flipping it around and making it slide back and forth and moving it in front of and behind the snowman as we're moving along here. So all of that is working here. And as we're moving, we're changing this move variable. But what this number is to start will determine where it is relative to everything else. That's going to make a little more sense when we move on to other body parts here, but let's start with the arm here. So I'm going to put the number 10 down here. I picked a Z position that is way more than I know it's going to be, and I just want to show you what that looks like right now. So let's click the green flag, and you can see that my arm is spinning around. I'm going to slow down that rotation a little bit so you can see it a little more carefully. You can go with whatever number you want here. I'm going to go 5 with a D and -5 with an A here. There we go. And now let's try spinning that around again. There we go. That's looking a little cleaner here. So the flip of directions kind of happens right in the middle there so quickly that you don't quite realize what's happening. But you can see that if you look at it in just about the right way, it looks like it's orbiting around the center of this snowman here. Okay, so we want to move it closer to the snowman. The best way to tell is to get it beside the snowman and then see how far away it still is from the body. So we're going to have to take that number and make it smaller. Let's try a number like 800 and see what that looks like. And let's click the green flag again. There we go. And that is still too far. Let's try 600. So you can, the creator of the elephant project had all these things kind of floating a little bit off of the body here, but I actually want these guys attached. Now it's not quite there, but it looks like it's getting closer here. I think the final number that I came up with was 540 for this first arm. And you can see that looks pretty good here as we spin around the body here. If we do it fast enough, you can see it does create that impression that it's orbiting around. Beautiful. Now that's going to be more apparent when we get the second arm on here. So I'm going to duplicate all these 4 blocks of code here. We actually don't need the first one that says switch costume to arm. because of course we were going to be doing another arm here, so we're already wearing the right costume. Remember that these variables are kind of stamped on because these are local variables. When this clone gets created, it's going to be given these numbers. But for our second guy, we're going to create different numbers. So let's duplicate the 3 blocks here, and and we're going to now change. We're going to keep that Z position the same because the other arm is going to have to be the same distance away. But that move, as I told you before, is going to dictate how far around the circle that is. Let's start this. Right now those 2 guys are overlapped, but if I take that second guy and move him 20 and then restart my program, you can see that he's a little bit off. And what's happened is he's rotated a little bit further along the line here. Let's try a bigger number like 50 and restart the program. And you can see that the bigger the number is, the more he's rotating around the circle here. Now again, it's a bit of trial and error. We're just going to play around with these numbers. The numbers I came up with that I think is going to work nicely is 90 here. And that again is just trial and error. So I've got my 2 guys on opposite sides of each other now. And you can see that I've got them rotating quite nicely around the center now. Now you guys might be able to play around with the numbers and get something that looks better. It's quite possible that a different number here might create more of a 3-dimensional illusion. That's a little bit too far off there, eh? I think I'm going to stick with like 550 here. Okay, so far so good. So you can see that we've got the thing spun around here. Now I'm just going to go ahead and place some other objects really quickly here. I've got my arm, I've got a little eye. Notice that every object, I've drawn these all by hand here, these objects are all placed relative to the center. So I'm going to want that eye to appear somewhere. Now the left-right part we're going to control with that move variable, but the height, the Y variable, does not change. It stays at 0. So if we want the eye high up, we have to place it above the center here to the spot that's going to be at the right height on this head here. And that's a little bit tricky to do. So what I'm going to do, especially because when I'm not running the program, when I'm placing the graphics, I can't see that snowman. He's invisible until I start running that project again. So I can stop and start the program as I'm moving this eyeball around, but then we run into stacking order issues and all kinds of other problems here. So what I'm going to do instead is we're going to actually paste this snowman. I'm just going to grab the entire thing and I'm going to paste it onto the background. This is just a temporary measure here. So let's go copy. I'm going to go back to my backdrop here, which has a nice blue pattern on it. And I'm just going to paste that snowman on. He automatically goes onto the same XY coordinates as the clone copy here. And the nice thing about that is that now when I go back to place my eyeball, as I'm designing it, let's bring it to the front right now so we can see it here. So I can slide it up and down the screen here until I know it's at the right height to be a snowman's eye. Now it's placed in the middle. We've got a Cyclops snowman. That's no good, but we'll fix that in a second. We just want to get the height right here. So that's good. Later on, as I said, we'll be deleting that snowman and we'll be going with the clone version in the middle. Though it doesn't really matter because when we run our program, the snowman and its copy down below are so perfectly superimposed on each other that it just looks like this one guy here. Okay, we're going to place our eyeball now. He's in the middle. Now we need to figure out where he is left and right. So first of all, let's switch costume to that eyeball. So let's go switch costume to eye. And we're going to, actually, let's just duplicate all this code again. So we've got our move, our Z position, and our create clone of ourselves. Let's just leave that at where the numbers are right now, and you can see that it's off to the side, the same way the arms are. That's not going to work. So let's start bringing the eyeball into the middle now. Let's type a smaller number, like 40, and see where that brings it. Well, that takes it right behind the snowman, so that's no good. Let's try 60. You just got to do a bit of trial and error here to get this working properly. I think what we actually have to end up doing here, and sometimes this is necessary, is we need negative numbers here. So let's try a number like -20. Well, that's bringing it around the circle here. Let's try negative 40. There we go. And that's right under the hat there, and that looks like a pretty good spot. Let's try negative 45. No, actually the other way, negative 35. There we go. Actually, negative 40 looks like it's in a pretty good spot, or maybe negative 38. So we're just going to position this until it looks just about right. Perfect. Okay, now we're going to do the same thing for the other eye, so let's duplicate it. Oh, actually, we want to make sure, sorry, before we do that, though, we want to make sure that our Z position is right here. So our eyeball, we will only know as we spin it around whether it's too far away, and look at that, it is way too far away here. So we're going to want to bring that a little bit closer then. Again, it's trial and error, but the number I found that worked was 300. Let me show you what that looks like. And there we go. Yeah, that's spinning around quite nicely here. Okay, great. So we're going to do the second eyeball here. The Z position stays the same because this eyeball is the same distance away, but now we need to pick a different number for where to place it. So we're going to use that move variable again. We're into negative numbers here, so let's try a bigger negative number, which will shift to the left. Let's try minus 50 here. Well, that's not quite right. Minus 55. Let's have a look at that. Whoa, I didn't change. No wonder stuff is messed up here. I still have the wrong Z position. 300. And that is looking pretty good. Watch what happens when I spin that guy around. Yeah, it looks like his eyeballs are kind of spinning around in 3 dimensions there. Beautiful. All right, so next up we're going to try the carrot. Now the carrot is one of the more complicated objects we're going to do here. You remember back in our 2.5D elephant tutorial here, we had the elephant's nose sticking out. So this is one area where we can really sell this 3D effect by having this object look differently depending on what angle we're viewing it from. You see how it looks like it's sticking out here, but when it's viewed from the foreground, there's almost no nose at all. And I'm going to show you how I did that, except this time we're going to do it with a carrot. So let's stop this and go back to our main project here. All right, so let's grab the same 4 blocks of code here again. We're going to change that first one to a carrot. Now, I'm not going to show you the trial and error process of placing these things. You're just going to have to take my word for it. So let's try a Z position of 250 here. That worked quite nicely in my tests. And we're going to do a move of minus 40. There we go. Let's have a look at what that looks like now. You can see that we got our nose placed there. It doesn't look very realistic right now. That's going to change in a little bit. But if you imagine the nose extending out from here, it'll make a little bit more sense to you. Okay, so let's try spinning that around. And you can see that it is in fact spinning with the eyeballs and the arms, and it looks okay. It's going to look much better in a second. So we're going to place that a couple of times, except every time it's going to be a little bit offset, as I said. So I'm just going to duplicate these 3 blocks. We're already wearing the right costume, and I'm going to duplicate them again here. So for the second set of numbers here, we're going to always leave that move in the same spot, but we're going to change that Z position. So we're going to change it by 100 here. We're going to go 350 here, and then 450. So each one will be about 100 pixels off from the one before it. So when I place this down here and then click the green flag, now again, it doesn't look like much when we're looking at it straight on, but when we move to the side, you can see we have an extended nose shape here that flips around to the other side when we come this way. And suddenly we've got a little bit more of an illusion of 3 dimensions here. Very cool. All right, let's just put the tip of the carrot in here. So I've got a sprite in here called Carrot 2. And I designed that to look like the tip of this carrot and to fit onto the other one. Again, with black lines along the edges here, and then no transition here. So let's place that so that it's exactly at the tip. Let's go ahead and switch costume to Carrot 2. And then we're also going to duplicate those three key blocks here. And let's see what numbers we want to move those to. So caret 2 is going to be a Z of 455. So it's kind of superimposed on top of this other guy. And the move is going to be minus 45. Again, just a process of trial and error here. Let's click the green flag and see what that looks like now. Looks a bit odd here, but when it's in motion, oh, that's not quite right, eh? All right, let's try moving it a little bit closer then. So let's grab a Z position and tell it to go to 425 maybe. Not too bad. Let's try 405. I think I put the guy a little bit too far away here. He does need to be higher up on the screen as well. So I'm going to go and adjust that costume a little bit and just move it a titch upward here. And hopefully that'll help it to center a little better on the screen on the rest of the caret. Let's try that now. All right, perfect. It ain't, but it seems okay. I'm going to actually expand it a little bit too. Looks like it's a little bit small here. And there are parts where it kind of breaks down a little bit, eh? All right, I'm going to play with those numbers a little bit and maybe come up with something better for the final project, but you're getting where I'm going with this thing anyway. All right, so rather than bore you with the details here, I'm just going to backpack in the rest of this code here. So we've got our button, which we've repeated 3 times. I actually have 3 different costumes here for the 3 different buttons. And the reason for that is because we can't change the Y coordinates of our object. We can only change its X coordinates. So the 2 eyes, which go beside each other, could have been the same costume. But because these guys are at different Y coordinates relative to the center here, I had to place each one as its own costume here. And meanwhile, I also have a foot here that's going to appear to the left and to the right here. We're going to use that same trial and error method for all of them, but I'm just going to save you the trouble. You can find the finished numbers. You can see them here on my screen. I'm just going to scroll through, and you can pause if you're looking for them. And that's going to place those objects down, the feet and the buttons. And there's really not much more to it. It was just a matter of trial and error, playing around with these, trying to get them the right distance away. So let's click the green flag here. You can see our snowman's more or less finished here. Beautiful. And as I spin him around, looks like he's spinning in 3 dimensions. Beautiful. We're just going to do a few little visual things to clean this up a little bit here. So for starters, I'm going to change my backdrop around a little bit. So I've got a backdrop here that has a little bit of snowy kind of, yeah, just a hilly kind of snowy area here in the background. I can go ahead and delete this reference object now that I'm done with it. So let's go ahead and do that. You can see that that's not going to affect the actual finished product at all. There we go. And now I just want to create a nice snowy little thing going on in the background here. I grabbed a snowflake from the Scratch library. It's colored blue, but I'm going to change it to white because the blue's not going to show up nicely here. So what I've done in the code here is, let me show you quickly what's going on here. When I click the green flag, we're going to set the brightness of these snowflakes to 100. Let me show you what that looks like. Let's set the size up to 100 here so that you can see there's my nice big snowflake on the screen here. And so when we set the brightness vector to 100, we basically turn it into a bright white. Then we're going to set a ghost effect to 10. That's just going to give it a little bit of transparency. That doesn't look very transparent at all. There you can see as we move that ghost effect up, it makes it more and more transparent. So set a transparency that you like for this snow here to make it look realistic. I'm going to go with a fairly slight one, like 20 here. There we go. Now we're just going to get into a forever loop where we're going to wait a random amount of time. Then we're going to go to a random x coordinate at the top of the screen here. I did a Y of 170 so that they would actually appear at the top of the screen rather than halfway off the edge here. Then I'm going to make a clone of myself. And as the clones are created along the top of the screen in a random place here, we're going to change their size. We want them anywhere from 2% to 8% of their regular size. So let me show you what that looks like. So quite small, but in a range from very tiny to a little bit bigger, basically. Then we're going to make them visible because they were hidden. And we're just going to have them fall to the bottom of the screen here. Now they're going to move a distance, it's a negative distance because we're moving down the screen, so from 1 to 3 here. So if we're moving 1 down the screen here, we want to get them at least 100 down. We could have done this in a forever loop and then if touching edge, leave the screen, but I'm just going to do something simpler here where we're repeating 100 times. And if it goes down too far or too much, it's not going to be a big deal, especially because it's against the snow, so it's not going to be too visible. Once this repeat loop runs out here, we're going to delete the clone. And in the end, we'll come up with something quite nice here. Let me show you what that looks like. And there's my snow. It's looking quite lovely. So we're just going to get a little festive music going here as well. Well, not really music, a sound effect. And over my backdrop, you'll find a file that says play sound sleigh bells until done. We'll get into a endless loop here. There we go. And now we're good to go. You could turn this into a little scratch Christmas card or anything else that you like as well. And I just think this is really cool. What neat technology. So experiment with this. Maybe you can fix my nose problem here and get something nicer going here. It looks like I didn't quite set this up properly. I noticed that in the elephant project, he had a big round end to the nose that basically covered up what was happening down below, and maybe that's what I need to do here, is do something a lot bigger at the end here that that will cover up some of those imperfections in the shape. Otherwise, though, I think this is looking quite lovely. So what other kind of shapes and creatures can you make? Please send them along to me at info@chromeworks.ca, and I'll show the best of them on next week's live stream. Thanks and enjoy.